Welcome to the viewers. Today we discuss the topic of the evaluations of important functions gt equals to t to the power gamma, and we have to evaluate the Laplace transform of gt, whatever may be as the notation we use, these or either these categories. So today we use the notation this. So you have to find the Laplace transform of t to the power gamma, suppose, and always here the given condition is gamma is greater than -1. Now for these conditions, at first it's clear that gamma is greater than -1, so -1 less than gamma less than 0, then we find, that means gt already is clear. If it is negative, then for 1 by t as t ft, that means gt tends to infinity, we find as t tends to 0. Hence gt is not a piecewise continuous function in any finite interval of t. So the conditions of existence of the Laplace transform violated. So the conditions of existence of Laplace transform gets violated. Then its Laplace transform still exists, since -0 to infinity t to the power gamma e to the power minus pt dt, that will be equals to mod of integral 0 to infinity t to the power gamma. If p is a complex valued function, then p can be written in the form of x plus iy into t dt, which will be less than equals to 0 to infinity t to the power gamma e to the power minus t dt, since that's cause is mod of e to the power minus it is equal to 1. That's why this is a cause, and which is known is convergent, that means which is convergent for gamma greater than -1 and x greater than 0. So the Laplace transform exists. Let gp equals to 0 to infinity t to the power gamma e to the power minus pt dt, and it is known as that gp is analytic in the domain real p greater than 0. So here we find the new term. This term is analytic. This analytic function actually comes in complex analysis basically. So it is not possible here to discuss rigorously what analytic function is, but in the chapter of complex analysis we will discuss later. Now we proceed to evaluate the value of the integral, and this is analytic. Okay, and on positive real axis, that is for p equals to x, which is greater than 0 for real values of x, that means for real values of x, then the value of integral becomes 0 to infinity t to the power gamma minus xt dt, because here t to the power gamma e to the power minus pt dt, pt is form of x plus iy, y part is 0, so only exists the x part. Now if we substituting these terms xt in terms of tau, so we'll get here 0 to infinity tau to the power gamma by x to the power gamma into e to the power minus tau d tau by x. After simplifications, then it will be by substitutions tau equals to xt. So it's clear, 1 by x to the power gamma plus 1, 0 to infinity gamma to tau to the power gamma e to the power minus tau d tau is equal to 1 by x to the power gamma plus 1, tau to the power, here we adjust something, plus 1 and minus 1, just to adjustment, into tau to the power gamma d gamma. Now we write it here, gamma function of gamma plus 1 by x to the power gamma plus 1. What will be the gamma function? By definitions it is 0 to infinity e to the power minus whatever may be the result into tau to the power gamma, it will be d tau. This is the main result. That's why if we consider here gamma plus 1, it will be here, it will be this one 0 to infinity e to the power minus tau to the power gamma minus 1 d tau. This is the formula, and if we are substituting it gamma plus 1, it will be gamma plus 1 and this. So on positive real axis, and positive real axis, Gp equals to gamma of gamma plus 1 by x to the power gamma plus 1 if p is equal to x, that will be greater than 0, real. The function gamma of gamma plus 1 by p to the power gamma plus 1 is analytic okay. Just a sort of corrections in the earlier pages. It should be noted here, if we consider on the real axis, that is if p equals to x gp, if we treat x in the place of p, we substitute it here p, so gp will be gamma of gamma plus 1 by p to the power gamma plus 1. The function is analytic in the domain real p greater than 0 and coincide on real axis. So by uniqueness property, fp must be equals to, that means gp must be equals to gamma of gamma plus 1 by p to the power gamma plus 1 in real p greater than 0. Therefore gp is equal to gamma of gamma plus 1 by p to the power gamma plus 1 is equal to 0 to infinity t to the power gamma into p e to the power minus pt dt. That will be Laplace transform of t to the power gamma for real p greater than 0, and therefore the Laplace transform of t to the power gamma for gamma greater than minus 1 exists and is given by L of t to the power gamma is equal to gamma of gamma plus 1 by p to the power gamma plus 1 for real p greater than 0. If we take the positive integer gamma is equal to n, then it will be L of t to the power n, that is gamma of n plus 1 by p to the power n plus 1, and it is clearly noticeable gamma of n plus 1 is n factorial by p to the power n plus 1. This is a result, and we make different type of Laplace transformation for this result, like L of t. What will be for n equals to 1 factorial by p to the power 1 plus 1, it will be 1 by p square. L of t square, that is 2 factorial by p to the power 2 plus 1, that is 2 by p cube. In this way we can find any other Laplace transform like t square t to the power 1. In fact, L of 1, that means t to the power 0. 0 factorial is 1 by definition, that is 1 by p. So Laplace transform of 1 is 1 by p. In this way, we find a special type of Laplace transform of functions. Thank you.